Hi and welcome to this video for the BTEC Applied Science Level 3, Unit 19, and we'll be looking at the final assignment within the unit and the walkthrough for it. So there's two pass criteria. We've got P5, P6, we've got one merit criteria and one distinction criteria. So starting with the pass. Pass is explain the operation and applications of capillary GC and HPLC instrumentation and measurements. So down here, we've got our P5. What it's wanting, learners will draw GC and HPLC and explain the function of the component. Note it says you can't just download a picture or photocopy it, not acceptable. So what we just need is two, roughly decent hand-drawn pictures, and you're simply going to say things like, on the GC, what is the oven doing? What is the capillary tube doing? For HPLC, much exactly the same in terms of the capillary, what's it doing there. So the GC should be talking about the temperature gradient involved with it, whereas HPLC, you've got the polarity and how they separate out the actual components. Most of that you've probably done in classwork with the theory for it. Fairly easy to get a hold of information for that. Little bit of research afterwards, so at least two specific examples for HPLC and GC, and I would say include references with these and how the techniques are used in the four applications. So for example, HPLC can be used to determine if there's any cocaine or its metabolites present in urine. So it's one of the ways of doing drug testing. Again, find a specific reference for that. So there might be a journal for it or a police force, a forensics department that talks about how they use that. So key thing there, do not just make this up off the top of your head. You should have four references for the four various things within there. Now, P6. So P6 is demonstrate accurately the identity and amount of analytes using qualitative and quantitative GC and HPLC data. Now, your college will not have either of those two pieces of equipment, so you'll be given some that the teachers probably, hopefully managed to steal from a nearby university or workplace or just, the internet in general. So what you'll be given is some spectra where it's got the various spikes on it, and it's a case of, say, based on the information, if cocaine comes out at 5 minutes, you're looking at the spectra, and does the spectra have a peak at 5 minutes? Can you say if cocaine's present? It may be another thing as well with sort of working out the amount of it. You should know based on the theory that a computer would actually measure the area under these peaks to determine the relative abundance for one of them to another. But if you're not given that information on peak areas to do so, then what it may just be a case of it could have just been simplified to looking at getting a ruler out and measuring peak height and doing a ratio comparison that way. So it's not strictly correct, but based on some assumptions about the shape and such, it's probably the best thing you can go with in a level 3 environment for working it out, as long as you're aware that in a workplace you would actually be looking at the area. So P5, bit of drawing, bit of theory, bit of research. P6, you'll be given a worksheet likely with some calculations to do and some qualitative statements to make based on if peaks are there or not. Now on to the merit. So merit, discuss how a method for finding the amount of a given organic compound in HPLC could be developed. This is quite tough in my opinion. It's probably harder than the distinction one. So what we need to do here is discuss how, from a starting point, so we are going to pick, for a specific given analysis, we're going to pick something that we want to try and search for. So any given random drug could even just be, say, caffeine, doesn't have to be anything exotic. Probably go for the simpler ones, caffeine, nicotines, vitamin C's, things like that. There'll be a lot more on those rather than, say, if you try to search methamphetamine, for example, because that is probably going to be behind journal paywalls and it'll be a bit tougher to find information for that. And your Google search history starts becoming a bit of a red flag at that point. So we want to look how to develop something to test for those. So you would do some initial research. You'd probably find a similar molecule, so something that's similar to caffeine, for example. What you would be trying to do is discuss what would be appropriate solvents and columns to use to measure caffeine. E.g., you would Google caffeine. Is it a polar or non-polar molecule? So do you want your solvents and the columns to either be polar, non-polar, or one of each? And then you would talk about, well, if you did a run through and the peak appeared right near the start, so we had a peak that was more or less instantaneous, is that good? Or do you want a bit of time for it? Was the peak big and huge and smeared out? Was it very little? And you need to talk about what refinements you can make to your practical to try and get these so that you have the nice, crisp, sharp peak that we're generally looking for in all of this analysis. Key thing with this, you will be doing a lot of research for it, references, sources of information here. So that's going to take a fair bit of time on Google, to be honest. Carrying out the practical work, no chance. I can't think of any college that would have easy access to a HPLC. So it's all based on a bit of theory, bit of guesswork, and you talking about the possible things that could go wrong and how you would correct them. Now, the distinction. Analyze how the separation from industrial chromatographic techniques may be optimized. So you can choose here, GC or HPLC. So if you've actually found out a fair bit of information for the merit, as it says, learners could extend the discussion on the HPLC, analysing variables in more depth. So you may have actually done it. If you've done the merit bit really well, you could have actually finished the distinction without even realising it. If you were struggling with this and you didn't find too much, you found bits and pieces, and it's good enough for the merit bit, GC, I would say, usually has a lot more on the internet for ease of use finding afterwards. Now, it gives you ideas of everything when it's talking about optimization. So how would the temperature affect it for GC? Would you want the temperature increase to be fast, slow? Would you want to go from 0 to 300 or 0, 20, 40, 60, 80 and a slow increase? For HPLC, the polarity, how would that affect it? So again, with all of these, we're going to be looking at column selection, temperatures that I've just mentioned there, the programming, so what I was talking about, how fast you want it to heat up. For HPLC, you could change the solvent actually during the practical. So what we start off with is pumping through, say, a non-polar solvent that gradually becomes more and more polar. So you can look up these terms, what's meant by isocratic elution versus gradient elution, and compare which of those you may have done this within your merit bit for discussing how to get your research for the specific analysis done well. And you can discuss the benefits and drawbacks of each of these within the distinction. May be aware that there's baseline noise. So what that means is that it could be you've got all of this maybe baseline noise that you want to try and get rid of because you want this peak to be nice and clear away from it. And it's a bit messy if it's drowning within all of this stuff around it. So how can we get rid of these? What else do we got? Analysis can be based on experiments where the center has a function in GC or HPLC. Again, no chance of that. Or on case study data. So you can probably find some research carried out on the internet for that. All of it's just to do with how would you optimize either the GC or the HPLC to choose one of them. Thank you.